Hello everyone, welcome to this class. In today's class, we are going to discuss about airfoil nomenclature in the subject aerodynamics. First of all, what is an airfoil? Airfoil is a cross section of the wing which will produce sufficient amount of lift by means of having the pressure difference. And airfoil is a very important parameter to describe or to decide the amount of lift generation. For that, the airfoil nomenclature study is very important. Airfoil nomenclature is nothing but naming the system or categorizing the airfoil shapes. Typically, it includes parameter like camber, thickness, maximum thickness location, represented in the standardized format, often using a combination of letters and numbers. It facilitates easy communication and identification of specific airfoil designs. And the efficiency point of view, these well-designed airfoils can maximize lift while minimizing drag, leading to improved fuel efficiency and performance. As well as control, airfoil design influences an aircraft's control and stability. Next, we can move on to the applications point of view. Airfoil design is crucial in various applications such as aircraft wings, helicopter rotor blades, wind turbine blades, and hydrofoils. As well as a proper airfoil design ensures a safe, stable flight by controlling airflow over the aircraft surfaces. Generally, we have two different types of airfoil. One is symmetrical airfoil, another one is unsymmetrical airfoil. A symmetrical airfoil is an airfoil shape that has the same curvature on its upper and lower surfaces. As well as it has zero lift angle of attack. That means that the angle of attack is, if it is zero, no lift will be produced in the symmetrical airfoil. Application point of view, how commonly it is used, the symmetric airfoil. The lift is not the primary concern, such as tail surfaces of an aircraft or rotor blades of the helicopters. It provides equal lift and drag characteristics at a positive angle of attack and a negative angle of attack. NACA 0012 is a widely used symmetrical airfoil in aerospace applications. And the cambered airfoil, in a cambered airfoil is an airfoil that has a curved shape, resulting in a difference in the curvature between its upper and lower surfaces. So lift generation is varying with respect to symmetric airfoil. Even at zero angle of attack, due to the camber, it produces lift. There is some amount of lift will be produced in cambered airfoil. Camber can be optimized for specific flight conditions to enhance the lift and reduce the drag. NACA 2412 is a commonly used cambered airfoil with 2% camber and 12% thickness. Now let's come to the components of this airfoil. There is a nomenclature. One is called leading edge. The leading edge of an airfoil is the foremost edge of the wing or blade where the airflow first encounters the surface. The shape can be rounded, sharp, or have various other shapes depending on the aerodynamic requirements. Leading edge shape influences how airflows over the airfoil. Plays a crucial role in the formation of the bound layer, affecting lifting and drag. Leading edge design is crucial for optimizing the aerodynamic performance and stall characteristics. The leading edge marks the frontmost point of the airfoil, where it first encounters the oncoming airflow. The shape of the leading edge is a crucial factor and it is tailored to suit the airfoil's intended function. For high-speed airfoils, and as found on modern aircraft, fighter aircraft, the leading edge is razor sharp. It is designed to efficiently slice through the air. In contrast, airfoils intended for greater lift at lower speeds, such as those on certain small engine aircraft, sport thicker and more substantial leading edges. Next one is called a trailing edge. The trailing edge is the rearmost edge of the airfoil. It's where the air recombines after passing over the airfoil. Shapes and angles at the trailing edge influences lift, drag, and other aerodynamic properties. Situated at the rear of the airfoil, the trailing edge represents the point at which the airflow over the upper surface converges with the airflow breadth. The design of this portion of the airfoil is just as vital as that of the leading edge. Its purpose is to ensure that the two airflows meet with the minimal turbulence. Next one is chord line. The chord line is a straight line connecting the leading edge and the trailing edge of the airfoil. The area above the chord line is upper surface. The area below is referred to as lower surface. Both the upper and the lower surfaces are divided by the chord line. A transonic that is just a bit below or above the speed of the sound brings some unique challenges. To keep air moving efficiently, supercritical airfoils work best in this situation. And also, what is a Mach number? Generally, we have to know that it is a ratio between the flight speed to the speed of the sound. The speed of the sound at a sea level, generally, it is 330 meter per second. And we can categorize the types of airfoil, that is types of flow based on the Mach number also. If the Mach number is less than 1, it is called subsonic flow. If it is equal to 1, that is called Mach 1 is called sonic flow. If it is 0.8 to 1.2, that is called transonic flow. If the Mach number is greater than 1, then it is hypersonic flow, sorry, supersonic flow. Finally, the Mach number, if greater than 5, then that is called a hypersonic flow. Then what is a mean camber line? The mean camber line is an imaginary line drawn midway between the upper and the lower surfaces of the airfoil. In a symmetric airfoil, the mean camber line is measured with the chord line. This line plays a pivotal role in quantifying the airfoil's curvature, the fundamental parameter of our lift generation. Much like the upper and lower surfaces for the chord line, the mean camber line has an upper camber and a lower camber also. Maximum camber. It represents the maximum curvature of the airfoil. Camber is maximum, then we can get the lift is higher at in the cambered airfoil. Then angle of attack. What is an angle of attack? It is a very important parameter in the aerodynamics. The angle of attack is a fundamental parameter in the aerodynamics for understanding and optimizing the performance and behavior of the airfoils on the aircraft. The angle of attack is a central concept in aerodynamics, representing the angle formed between the airfoil chord line and the direction of the relative airflow. This angle is a significant influence. However, the airfoil's performance affecting both lift and drag. And we should know what is the maximum thickness of the airfoil as well as maximum chord line. So those kind of things we have to know in the airfoil, as well as we have another thing is called NACA series, NACA. NACA means National Advisory Committee, the Council for Aeronautics. So it gives four-digit series, six-digit series like that. You can have knockout series airfoil. We will discuss it later. How to find the maximum thickness of the airfoil as well as the position of the camber. Everything we can do. We can find it easily. We will do all the things in the next class. So finally, I will thank you and all for this nice contribution to this class. Thank you once again.